Okay, for 65, I set up the table already. I set it up in a different orientation because I needed the space, and you probably should do the same thing too. So the ditto marks just represent the $2,500 that I just didn't want to write it over and over again. But notice it's all the same structure. You have the rate here, the end value right here, and here again, and then 10. Oops, did I switch over the... Oh, shoot, I think I looked at number. The numbers, the answers will be right. It's just that I wrote 20 on most of them, but they're all 10. So let me just go ahead and fix that. So it's going to be 10, 10, 10, 10. And so this would be 120. This would be 40. And this would be 20. Okay? When you punch this into the calculator, so you simplify the parentheses, and you get 3,047, 49, and then for the next one it's 3,050, 48. For the next one it's 3,051, 99, 3,053. Now it's zero. It's not exactly 3,053, but it was like 99 cents, and the next number was like an 8 or something. So you round it up, so you got $3,053. And this one is 3,053.49. Okay, for continuous compounding, you use the PERT formula, which is this one right here, where you put P e to the RT. And so it simplifies to this. Punch it into the calculator, and you get 3,053 with 51 cents. Alright, so 67 is very similar, very like number 65, just the different rate. Okay, but the principle's the same. Oh yeah, and different time, 20 years instead of 10. So you input these numbers into the calculator. So what I did is I took the parentheses and I simplified each one all the way down. Now this, when I put it into the calculator, I did not put 1.003. I actually kept all of the, the answer with all its decimals as much as fit on the calculator. Then I raised it to the 240th power. Then I multiplied by 2,500. Okay? So don't use a rounded number. Keep all the digits that are on the calculator screen. So for the first one, you get 5,477 with 81 cents. For the second one, you get 5,520 with 10 cents. Then you get 5,541, 79 cents. Then it's 5,556, 86 cents. You get 5,563 with 61 cents. And then for the last one, for continuous compounding continuously, you use the E. So 2,500 times e to the 0.8, and you get 5,563 and 85 cents. For number 69, it's compounded continuously, so it's the PERT formula for all of them. So in pink, what you see is the simplified exponent. Okay, so in green, you see the two numbers just exactly as they're given in the formula, but then in pink you have the simplified one. So then you plug in you plug it into the equation, and you get into the calculator, and you get 12,489 And then for this one you get 17,901. For this one you get 26,706. And then 39. 59. And then finally 88,668.67. Alright, so 71 is just like 69, just of course different rate. This is 3.5%, but for the same number of years as number 69. And again, I wrote in pink the simplified exponent for each one. So when you input this into your calculator, you get for 1, let's see, for 1 year, for 1 year that would be 12,427.44. 10 years it's 17,028. Then 24,165.03 and 34,291.81. And then we have 48,662.40, and finally 69,055.23. For 79, they're talking about radioactive decay of carbon-14, and so they want you to determine the initial amount, so when T is 0. So I went ahead and replaced the T with a 0, and so 0 over 5,700 is 0, so this becomes 10 times 1/2 to the 0 power. Well, we know that 1/2 to the 0 power, this part is 1, so it's 10 times 1, so the answer is 10. Let's see, in grams, so 10 grams. Okay, for part B, determine how much is present after 2,000 years. So Q equals 10 times 1/2, 2,000 over 5,700. So just punch that into the calculator. So I would put 10 times 0.5 to the power of, and you could put it into, not put in as many digits, you could just cross out by 100, so you could just put 20 over 57. Make sure you put parentheses in your calculator. So you would put 10 times 0.5 to the power of, left parenthesis, divided by 57, close parentheses, and then equal. And so you get 7.84 grams. Okay, and then for C, they want you to graph from T equals 0 to T equals 10,000. So remember, this is, let me see, let me just write it over again. T over 5,700. So the reference points are -1, B, the base is 1/2, 0, 1, and 1. I'm sorry, I forgot to switch it. 1/2. Let me fix it. It's 1 over B for the -1, so it should be 2, right? And then from there, we look at the transformation. So I have the A value is 10. So this is the A value, and this is the B value that creates a horizontal, in this case it's going to be a horizontal stretch of 5,700, because you could think of it as 1 over 5,700, like that, times T. That's the same thing as you see there. So then remember how you take the reciprocal? So then that means that the x's get actually multiplied by 5700. So it's going to be 5700x, and the y's are going to get multiplied by 10, so 10y. So the transformed points are going to be negative 5700, 20, and then 0, 10, and then 5700, 5. Okay, so they only want you to go from 0 to 10,000 for the domain. So I'm not going to plot this point. Okay, I'm going to start here and plot the next one. So it's going to be something like this. This is Q, this is T, and so I'll make this 10, so that makes this one 5. So 0, 10, and then 5700 would be about, just putting it somewhere, and then 10,000 would be maybe about here. And when you plug in 10,000 for T and plug it into a calculator, you get the point. So 10,000, let me just put it here, gives you 2.96. Okay, so that's the ordered pair for 10,000. So 0, 10, 5700, 5, so that'd be about here. And then at 10, it's 2.96, so almost 3. So it's going to be about here. So this is the piece of the exponential function that they want to see. And that's it. For 83, it's asking if this is a, let's see. It says true or false, f of x equals 1 to the x is not an exponential function. And the answer is true. It's not exponential. Why? Because with 1 as a base, it's basically just a line, because 1 to whatever power you put in is 1, right? So this is actually the horizontal line, y equals 1. So the statement is true, it's not an exponential function. Alright, so for 85, you have to determine which equations may be represented by the graph. So the graph shows exponential decay, okay, and it shows a translation going up. Okay, so this one, because remember E is approximately 2.7, right? So this one's going to be a growth. So this one we can cross out. The next one is a decay because of the negative x. That's going to make E the reciprocal. So this one would be a decay, but that negative flips it over the x-axis. So that one's out of the question. C is also a decay because of that negative x, but the negative 1 has a translation down, so that one's out of the question. And so D is also a decay because of the negative in front of the x makes the E 1 over E, makes it a reciprocal. And it is translated up, so this is the only one that matches, that could possibly match that graph. So we have to match the equations with the graphs, okay? They've labeled them, they're labeled A through F. So the first 3 equations are growth equations because the base is greater than 1. And notice how it's progressively a bigger base. So 2, E, which is 2.7, and then 10. So then the steepest graph is going to have the base 10. Okay? So that means that 10 to the x would be D. Because of these three graphs that are growth, these 3 right here, this is the steepest. And then F is the least steep one, right? It grows slower than the 3. Then it's the slowest one of the 3, right? It grows the slowest. So that would be the first one that is on there. So let me just change it to pen. So that would be F. And then so the middle one would be E. Okay, now